we're going to draw the derivative of this. This equation looks like a cosine x plus 2. Now, all we do, we first look at this graph to find the first derivative, is to look where it has a slope of 0. So at 0, do you understand the slope is 0? So I'm going to put a dot at 0. This is my slope graph. Do you understand at pi, my slope is also 0? And at 2 pi, my slope is also 0. At these 3 points of the graph, your slope is 0. So you have 3 points of your graph. Now let's look at this point right here. That looks about, if you look at this line, isn't that about a slope of 1? If you look at the points, you can kind of see that's about a slope of 1. So what, oh, sorry, this is a slope of -1. We okay with that? So right here in the middle, does it look like your slope is about -1 from the dots given? Is that okay? About. Over here, between these two dots, does it look like this is about a slope of +1? So right here in between, it looks like about a slope of +1. Now, by the way, if this is cosine x plus 2, wouldn't the derivative be negative sine x blank plus 0? Does that look like a sine graph? Negative? So can it kind of verify us? Yeah. So it should look something like this. If you know your functions, it makes life a lot easier sometimes. By the way, this would be y prime. Now our next graph is we're going to take the derivative of this blue one. I'm just going to do it on the same graph. Now if this is sine x, negative sine x, what's the derivative of negative sine x? Positive cosine x. So it could give us an idea of what we're getting into. Anywho, what's the slope at this point right here? 0. So will my slope be 0? Isn't the slope 0 here as well? Are we okay? What's the slope at this point right here? Looks about a +1-ish. So we go up here. Slope is +1 at that point. At this point, isn't it about -1? Looks like it's going down about a -1. Here, isn't it going down about -1 as well? Does that look right? That looks like it's going downhill about 1. Now, does that look like a V? Some of you would put a V, but if you know enough about trig functions, you should realize it's a cosine-ish graph. So it's negative cosine, so it's going to look more like this kind of shape. Again, right now you don't know a lot about which way it curves. You'll learn over time how to tell which way it curves. Anyways, this graph in red is the second derivative. So the key to find derivatives, look for slopes of 0, and then look for other points that you could kind of guess the slopes, and from there you can get a trend of what the graph will look like. Pretty good trend. The red is the second derivative, the blue is the first derivative. Okay, for 16 or 116, you have the velocity function of some object moving. It wants a5, which is the acceleration at 5 seconds, minutes, whatever t stands for. It also wants the acceleration at 10. So basically, acceleration is the derivative of velocity. So all you're really doing is taking the derivative of velocity. That's a quotient rule. So derive the top, you get 100. Leave the bottom. Minus, leave the top. Derive the bottom. And then square the bottom. Now, do I have to simplify that? No, but am I plugging in more than one value? Yes, so could it be helpful to simplify it because I'm going to keep putting more than one value in? Now, could you also basically have done this on your calculator? Could you just find the inderive at 5, inderive at 10? That would also be useful, but be able to do both types. So can I replace v prime t with a of t. Is that okay? And then I'm going to simplify the top. Now, real quick, do you understand there's 100 in both of these? So I'm actually going to leave the 100 out front. And then, isn't this 2t? And then isn't that 15 minus 2? Because I broke the 100t out. Oops, no. It's 2t plus, isn't that a 2t right there? I missed that. Plus 15, and then this looks like it's a 2t. I lost a t, but it's minus 2t, right? Kind of messed up. I could have skipped a step there to write it twice. Do the t's disappear on top? It looks like it. So basically, let's do a of 5 is going to be 100, and on the top, don't these cancel? So I'm stupid, I just put times 15, we know what that's going to be. Over 2 times, don't we plug in 5 for t? F of 5, again these canceled, so we have 1500 on top, and this becomes 10 plus 20, 15 is 25, 25 squared. So it looks like we have 1500 divided by 25 squared is what? 25 squared is 625. And if you did that on your calculator, is it 2.4? Trust that's the answer. I don't know it. Are we okay with that? So the acceleration at 5 seconds or whatever is 2.4. That's how fast, that's the rate at which the velocity is changing. How is the velocity changing? Changing 2.4 something per time. We don't know the exactness. And if we want a of 10, same idea, except now I can combine those. I'm just going to simplify that. 1500 over 2 times 10 plus 15 squared. Looks like that's going to give us 1500 over 20 plus this is 35 squared. And we got 35 squared? Is it 1225? Is that right? 35 squared? And then if we divide that, what do you get? Could someone tell me that? 1.224. That's the acceleration at 10. That's the acceleration at 5. You could have done this all simply with your calculator by taking this equation, driving at 5, driving at 10 as well. Make sure you can do both methods. Now, real quick, if that was a position graph to start with, and it wanted acceleration, do you understand you do 2 derivatives, and then plug in 5 and 10? If that was s of t to begin with, a position, you have to do 2 derivatives to get to the acceleration graph equation, just so you know.